Number 29. A 120 volt heating element has a resistance of 30 ohms. How much power does it consume? So power in terms of E and R is E squared over R. So power is 120, don't panic, squared over 30. So we have 120 times 120. I'm going to show you, no I'm not. I was going to show you a shortcut, but I'm not going to do that. 0, 4, and 2. And then you are over under this 1 to get 2 and 1 and add. Now that I have that answer, and let me check it just to be sure. Something, I know the 144 is right. It's my zeros that yes. I will go ahead and show you the cheat way there, but let's finish this problem. So 14,400 over 30. I am going to cancel one set of zeros. Doesn't help too much, but maybe a little bit. Divided by 3. And that would be 12 with 2 left. That would be 8 with none left. But don't forget, you still have that 0 that you have to work through. So 480 watts. And let me show you the trick to multiply those without the long way. 120 times 120. Bring these two zeros down. And 12 12s are 144. That's a little bit faster than having to multiply it. But if you need to multiply it, it's okay. All right, a 240 volt appliance has a resistance of 80 ohms. Find its power consumption. So power is E squared over R. So we have 240 squared over 80. So we've got 240 times 240, and I am going to do the shortcut here. I'm going to bring those two zeros down. That one just went away. And then I'm going to multiply around it. So this would be 16 and 9, 8 and 4. And you know I'll be checking this one. $240 squared. Yes, is 57,600 divided by 80. I would think a calculator would be okay on this one, especially on a timed test. This would just you kind of get lost in the weeds here. But we'll finish it because that's what I'm supposed to do. Don't lose this 0. So I'm thinking our answer would be power is 720 watts. A laptop charger operates at 19 volts and provides 3.5 amps. Find the power output. So here is pi. P equals IE 3.5 times 19 can tell you that we're going to have 1 scoop. 27 and 4. And then 5 and 3. I am going to check this, but we have 1 decimal place, so that's 1 scoop right there. Let me just double check because something doesn't look right. But I'm tired. Yep, 66.5 watts. A welding machine requires 50 amps of current and runs on a 220 volt supply. How much power does it consume? Again, we have pi. I is 50. E is 220. And you absolutely can use your shortcut here. 220 times 50. Bring the zeros down. And then multiply around them. And that would be 11,000 watts. That's a lot of watts. But a welding machine is a pretty strong appliance. So that always ask yourself, does it make sense or is it reasonable?